This video is about the trig functions sine, cosine, and tangent. This is AP Precalculus topic 3.2. If you appreciate this content, please give it a like. In the previous video, we learned that given an angle in standard position with terminal ray intersecting circle of radius r at the point x, y, the sine of angle theta is y over r. The cosine of theta is x over r, and the tangent of theta is y over x. We will use these little formulas over and over again, so pause the screen, write them down, and memorize them right now. Problem number 1. The figure shows a circle centered at the origin with an angle theta in standard position. The terminal ray of the angle intersects the circle at P. The coordinates of P are x, y, and the coordinates of Q are x, the opposite of y. Which of the following is true about the sine of theta? First of all, because we are given this point 7, 0, we know that the radius of the circle is 7. So we know that the sine of theta will be y over 7. So the answer is D. Sine theta equals y over 7 because it is the ratio of the vertical displacement of P from the x-axis to the distance between the origin and point P, which is just a long way of saying that sine theta is equal to y over r. Number 2. The figure shows a circle centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point Q. The coordinates of P are 4, 3, and the radius of the circle is 5. What is the value of cosine theta? To answer this question, we need the x value and the y value of Q. In other words, we need the horizontal displacement and the vertical displacement of point Q. Because the point Q is at the same height as point P, it has the same vertical displacement, the same y value. So it'll be something, 3. The horizontal displacement of point P is 4. Therefore, the horizontal displacement of point Q will be -4. We have memorized that the cosine of theta is equal to x over r. So in this case, the cosine of theta will equal -4 over the radius of 5. So the answer is A. By the way, it doesn't matter whether the negative sign appears in the numerator, in the denominator, or in the middle. -4 over 5 is the same as -4/5. Number 3. The figure shows a circle centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. The coordinates of P are x, y, and the coordinates of r are the opposite of x and the opposite of y. Which of the following is true about the cosine of theta? The terminal ray of angle theta passes through point P, so I'm not sure if point R has anything to do with it. The cosine of theta is defined as x over r, the horizontal displacement divided by the distance from the origin to this point. At point P, the horizontal displacement is given by x, and the radius r is clearly 3. We can tell because of the point 3, 0. So the cosine of theta will equal x over 3. So the answer is A. The cosine of theta is equal to x over 3 because it is the ratio of the horizontal displacement of P from the y-axis to the distance between the origin and point P. Number 4. The figure shows a circle centered at the origin with an angle of measured theta in standard position and the line segment connecting points P and R. The terminal ray of the angle intersects the circle at point R. So this is the terminal ray of the angle. The coordinates of P are 5, 12, and the radius of the circle is 13. What is the value of tangent theta? Because we have a line segment connecting point P and point R is going to be the reflection of point P over the origin. Therefore, the horizontal displacement of point R will be the opposite of the horizontal displacement of point P. So, -5. Similarly, the vertical displacement will be the opposite of the vertical displacement of point P. So 12 becomes -12. So we have the coordinates of point R. Since this is the point on the terminal ray of angle theta, we can use these values of x and y in the definition of tangent. Tangent theta is defined as y over x. So in this case, tangent theta will equal -12 divided by -5. A negative divided by a negative is a positive, so tangent theta will equal 12 over 5. So the answer is D. Number 5. The figure shows a circle centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point R. That means R is the key point to observe. The coordinates of point P are x, y. The coordinates of point R are opposite of x, y. Let's put that in the picture. -x, y. This is what matters. Which of the following is true about the cosine of theta? Notice that the radius is 5 based on the point 5, 0. We know that the definition of cosine is that cosine theta is equal to, well, I started to say x over r. But because we are using the opposite of x, let's not say x over r. Let's say the horizontal displacement divided by r. So with the point r being on the terminal ray of the angle, the horizontal displacement is -x. So cosine will be -x over r. Oh yeah, and the radius is 5, so that means the cosine theta will equal the opposite of x over 5. So the answer is B. Cosine theta equals the opposite of x over 5 because it is the ratio of the horizontal displacement of r from the y-axis to the distance between the origin and r. Number 6. The figure shows a circle centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at S. That means S is the point that matters this time. The coordinates of point P are 15, 8, and the radius of the circle is 17. What is the value of sine theta? Well, we need to figure out what the coordinates of point S are. And point S and point P have the same horizontal displacement. So that's going to be 15. The vertical displacement of S is going to be the opposite of the vertical displacement of P. So that's going to be -8. Now we can use these numbers in the definition of the sine theta. The sine of theta is defined as y over r. So in this case, the sine of theta is going to equal the opposite of 8. All right, that's instead of y, I'm really thinking the vertical displacement. So the vertical displacement divided by the distance from the origin, which will be 17 which we can see in the point 17, 0. That gives us the radius. So negative 8 over 17. So the answer is A. Number 7. The figure shows a circle centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point S. So point S is the one that matters. The coordinates of point P are x, y, and the coordinates of S are x, the opposite of y. Whenever they start talking about the coordinates being x and the opposite of y, or the opposite of x and y, I start saying horizontal displacement and vertical displacement to avoid confusion with these letters. Which of the following is true about the sine of theta? We know that the sine of theta is defined as, all right, and here I would normally say y over r, but I'm going to say the vertical displacement divided by the radius. So what is the vertical displacement of S? That is given by the opposite of y. So vertical displacement divided by the distance from the origin. That's going to be 14 as revealed by the point 14, 0, telling us the radius. So the opposite of y over 14. So the answer is D. Sine theta equals the opposite of y over 14 because it is the ratio of the vertical displacement of S from the x-axis to the distance between the origin and S. Number 8. The figure shows a circle centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point Q. That means point Q is the one that matters this time. The coordinates of point P are x, y, and the coordinates of point Q are the opposite of x, y. So I'm going to talk in terms of horizontal displacement and vertical displacement to avoid confusion for this problem. Which of the following is true about the tangent of theta? We know that the tangent of theta is defined by, now instead of saying y over x, I'm going to say the vertical displacement divided by the horizontal displacement. The vertical displacement of Q is y, and the horizontal displacement is given by the opposite of x. So let's look for the one that says tangent theta equals negative y over x. The answer is C. Tangent theta is equal to negative y over x because it is the ratio of the vertical displacement of Q to the horizontal displacement of Q. Use the information below to answer questions 9 through 14. The figure shows a circle with radius 10 centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. Okay, that's the important one. The coordinates of P are 6, 8. The coordinates of Q, R, and S are the results of reflecting the point P across the y-axis, the origin, and the x-axis, respectively. So before even looking at the rest of these questions, we should be able to figure out the coordinates of the other 3 points. Let's see, point Q will have the same vertical displacement as P, which is 8. And it will have the opposite horizontal displacement, so negative 6. The point S should have the same horizontal displacement as P, therefore 6. And it will have the opposite vertical displacement as P, therefore negative 8. The point R should have the same horizontal displacement as the point Q, therefore negative 6. and the point R should have the same vertical displacement as point S. Therefore, -8. Number 9. What is the cosine of the angle whose terminal ray intersects the circle at point Q? Let's record the coordinates of point Q so we can scroll. Q is at -6, 8. Also, notice that the radius is 10 as given by the point 10, 0. Be careful not to say cosine theta for this problem, because theta is the angle whose terminal ray goes through point P, not point Q. Instead, we will go straight to the answer. The cosine of this angle is the horizontal displacement divided by the radius. So that's going to be -6 divided by 10, which reduces to -3/5. So that's it for number 9. Number 10. What is the sine of the angle whose terminal ray intersects the circle at point S? There's point S right there. Let's just write that down. 6, -8. And the radius is 10. The sine of this angle will be the vertical displacement divided by the radius. So -8 divided by 10. This will reduce to -4/5. So that's the answer to number 10. 11. What is the tangent of the angle whose terminal ray passes through the circle at point Q? Remember, point Q is -6, 8, and we know the radius to be 10. The tangent of the angle will be the vertical displacement divided by the horizontal displacement. So that's going to be 8 divided by -6. This reduces to -4/3. So that's the answer to number 11. Number 12. What is the cosine of the angle whose terminal ray intersects the circle at point S? Point S, which is right here, is the point 6, -8. And the radius is still 10. The cosine of the angle will be the horizontal displacement divided by the radius. So 6 divided by 10. This reduces to 3/5. So that's the answer to number 12. 13. What is the sine of the angle whose terminal ray intersects the circle at point R? I need to scroll up for point R. Point R was -6, -8. -6, -8. With a radius of 10. The sine of the angle will be the vertical displacement divided by the radius. So that's going to be -8 divided by 10, which reduces to -4/5. That's the answer to number 13. 14. What is the tangent of the angle whose terminal ray intersects the circle at point R? Well, point R is 6, -8 with a radius of 10. The tangent of the angle will be the vertical displacement divided by the horizontal displacement. So -8 divided by -6. A negative divided by a negative is a positive, and 8/6 reduces to 4/3. So that's the answer to number 14. 15. Let theta be an angle in standard position whose terminal ray intersects the circle at point P and coincides with the line y equals -3/4 x in quadrant 2. The coordinates of P are -8, y. What is the y coordinate of point P. In a previous video, we learned that tangent theta is the slope of the terminal ray of theta. But in this case, the terminal ray coincides with the line y equals negative 3/4 x. At a glance, we can tell that this line has a slope of negative 3/4. So this slope is the tangent of theta. At the same time, the tangent of theta is the vertical displacement of P divided by the horizontal displacement, so y over negative 8. But we just found that the tangent of theta is negative 3/4. So making that substitution, we have negative 3/4 is equal to y over negative 8. We can solve this equation for y by multiplying both sides by negative 8. A negative times a negative is a positive, and 3 times 8 is 24. So y is equal to 24 over 4, or y is equal to 6. So that is the answer to number 15. 16. Let theta be an angle in standard position whose terminal ray intersects the circle at point P and coincides with the line y equals negative 5 over 7x in quadrant 2. The coordinates of P are x, 12. What is the x-coordinate of point S? My strategy will be to find the x-coordinate of point P, and then the x-coordinate of point S will just be the opposite of that. This negative 5 over 7 is the slope of the line that passes through point P. So let's get that written down. So we know that the slope is negative 5 over 7. And we also know that tangent is the slope of the terminal side of theta. So that tells us that the tangent of theta will also equal negative 5 over 7. However, we also know that the tangent of theta is defined as the vertical displacement divided by the horizontal displacement. In other words, 12 over x. But we already know that the tangent of theta is negative 5 over 7. So making that substitution gives us negative 5 over 7 is equal to 12 over x. We can solve this equation by cross-multiplying. Negative 5 times x will equal 7 times 12, which is 84. Dividing both sides by negative 5 gives us x is equal to 84 over negative 5. Therefore, the x-coordinate of point S will be positive 84 over 5, the opposite of the x-coordinate of point P. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.